choose, that is the main work. Choose that technique and create that polynomial. You just do derivative or nothing. Important or theoretically important here, the asking point xp is coincide along with the beginning point or coincide along with the last point. If it is not related to this point, then as usual laborious process, you have to use the technique, you have to create the polynomial, do the derivative. If it is given points, then your formula will be reduced and nice formula will be created. Using that formula, you have to solve some nice example, and that suppose for any data sets it will be asked to you. Suppose last day you have done the last class, what is the initial velocity, what is the final velocity, like that type of things is very practical. The initial point or last point, isn't it? Then your formula will be reduced. So for that purpose, important thing, suppose x values are equally spaced, and x values are equally spaced, and asking point derivative, you have to calculate derivative dy by dx at the initial point x0. X0 is the first value of x, and that x0 asking point is coincide along with the first point. Also belonging at the first point in this neighborhood, it is lying because it is coincide along with this point. So you will use which technique? Logically, which scientific technique you will use to create the polynomial? X values are equally spaced. Tell me quickly. Asking point is coincide along with the first point. So obviously that point is in this neighborhood. Which interpolation techniques you will use to create here? Newton forward interpolation? Yes or not?
Yes.
Okay. Now bolo. So let's polynomial with the help of this. Y equals to 5x, that will be y0. In that your polynomial. Where u equals to x minus x0 by h. So can you able to do this now polynomial? Can you able to do this polynomial derivative with respect to x? How you will calculate derivative of this? dy by dx. Dy by dx, it is directly related to u. So first do with respect to u and then u with respect to x. That is the chain rule. Okay. Is the transform variable, u is x minus x0 by h. So what is du by dx? Du by dx is 1 by h. That du by dx, you just put 1 by h outside, and inside that expression, you just do derivative with respect to u. Is it clear? Is it clear?
Yes, sir.
So first term is constant. So with respect to u, derivative it is du by dx is 1 by h. That is I am writing here. That is I am writing here. Okay. So inside I am doing with respect to u. So y0 is constant. So that is 0. What is the derivative of this term with respect to u? U del y0 with respect to u derivative, that will be del y0. So what is this expression with respect to u derivative? U square minus u. U square minus u. Its derivative 2u minus 1 by 2. Del square y0. So this expression also you have to do with respect to u derivative and this term. In that way, step by step terms will be there. Isn't it?
Yes, sir.
Okay. Again, if it is asked to you find out the second derivative. Second derivative, you just do this term with respect to u again. So d2y by dx2 will be ddx of dy by dx. But dy by dx is directly related to u. So do first with respect to u and du by dx again multiply by the chain rule. So again 1 du by dx multiply along with this term. So 1 by h square will come. Then constant, this term constant. So your derivative will start from here. With respect to u again, it will give you del square y0. Basically 2u derivative is 2 and below 2. So 2 cancel, del square y0 first term. Then its place will be 6u minus 6 by 6. 6u minus 6 by 6 del q y0. In that way, your derivative of second derivative also you may be able to calculate. Now logic is, if your asking point is the initial point or first point, okay, then what will be the u? You know u is x minus x0 by h. So if x is x0 means first point, then u will be 0. Isn't it? Is it clear? U will be 0.
Yes, sir.
Okay. Then if I will do, if it is asking to you find out the derivative at the first point, so dy by dx at x equals to x0. So in this expression, overall expression, you have to put u equals to 0 wherever u is there. In this expression, wherever you do have u, put u 0 because of this. Because at the first point u is 0. So in this expression, put u 0. You will get a nice expression. That expression is nothing but 1 by h, outside 1 by h, inside first term del y0. This is the constant term. Second term u0. So it will be del square y0 by 2. Third term will come as this term 0, this term 0. So 2 by 3, 2 by 6 means 1 by 3 del q y0. So del q y0 by 3. And next term will come as del 4 y0 by 4. Next term will be del 5 y0 by 5. In that way, that calculation I am not doing, but that nice expression alternating series you will get. Outside 1 by h means you just divide overall expression by h, and all these elements rearrange by an alternating series, and every term divide by the corresponding term value. Means first term by 1, second term by 2, third term by 3, and term is plus minus, and that above elements are nothing but in the difference table the upper diagonal element. This is the first difference value top element, second difference value top element, third difference value top element, fourth difference value top element. In that way, you may able to calculate derivative at first point. That derivation I have not done in left class, okay? But simply I was written that this formula. Is it clear? Same formula I was written in the lab class. Who has done the lab class CS1 group? Are you seeing this formula? dy by dx at first point.
Yes, sir.
So how this formula is coming? Is it clear now?
Yes, sir.
Very good. So similarly, this formula is easy to remember. Okay, these are the upper diagonal elements rearranged in an alternating series. Okay, but in second derivative there is no linearity, at least. So try to remember at least 3 terms at least. So if I will put d2y by dx2 at x equals to x0 means first point at x equals to x0, then in this expression I have to put u0. And your expression first term will be del square y0, second term del q y0, plus third term will be 11 by 12 del 4 y0. At least these 3 terms you just try to remember. Next term will come as suppose 111 by 113 del 5 y0 like that. Okay, but I am not going to for that. Actually, there is no any linearity to remember. So at least 3 terms you just try to remember. First 2 terms very simple. Third term 11 by 12. And starting from second difference minus third difference plus 11 by 12 fourth difference. Outside 1 by h square. So second difference, second derivative at initial point or first point, that is also, if 5 points is given to you, at least you may able to calculate. With respect to 5 points, up to 4 difference you may able to calculate. So using this formula, you can able to calculate the second derivative also. Is it clear? Okay. These two formula is clear or not? Derivative at first point.
Yes, sir.
Yes.
Now come to this example. Okay. Are you seeing this example? Nicely, you just try to study. Calculate y dot 0. Y dot 0 means derivative of y dy by dx at x equals to x0. And then x0 is 0. Means derivative at the first point, isn't it? From the following table of the function, basically this tabulated value is for this function. Sometimes continuous function is not given to you, but it is written here. For this function, this is the tabulated value. Sometimes this functional structure will not given to you, only discrete data points is given to you, and that is why we are studying these topics or numerical techniques. That is given here because of verification purpose or to calculate the error. Because with the help of numerical techniques, whatever the value I am getting, that is the better approximate result. But what or how much it is differ along with the exact, so sometimes we may able to verify the how much error is there. Okay. Besides that, it is asking to you that type of question also. Also calculate the error involved. So how we will calculate error? Means from exact how much it is deviated, how we will calculate. So for this function, you may be able to do mathematical derivative. With the help of your knowing formula, dy by dx is, what is the derivative of log x? Dy by dx of 1 by x plus 2, and in log, basically this is 10 base, so log 10e. If it is log e base, then 1 by x plus 2 only, and log e base e will be 1. So here is also you have to put some value, log 10 base e, that value, and along with 1 by x plus 2, that is you have to calculate. Now value, derivative value means at x equals to x0, dy by dx at x equals to x0, that will be 1 by 2, because x is 0, log 10e, half into log 10e. That value, if you will multiply, its numerical value will come like that. Okay, 0.2171. Okay, now basically these data sets is telling you for this function. Actually, if I will put in place of x here, log 10 base x0 2 means log 10 base 2 value will be this, log 10 base 3 value will be this, log 10 base 4 value will be this, like that. Basically for this function, this is the discrete data sets. Now logic is, so you forget about this function. With the help of these data sets, you just calculate numerical derivative at the initial point or first point. So for that purpose, these data sets you have to create the difference table, because you need, for this simple formula, you just see, for this formula you need these elements are the upper diagonal elements in the forward difference table, and you have to rearrange in alternating series, you have to divide by h. So you just calculate this difference table. Okay, 0, 1, 2, 3 and 4, and corresponding y values are given to you, 0.3010, like that. These all values I am considering in y column. Okay, now I am calculating the difference. The difference table calculation idea you do have. Difference table calculation idea you do have, or again I will repeat. Subtract this from this, put that value here. Subtract this from this, put that value here. Subtract this from this, put value this. In that way, first difference column. After getting first difference, with the help of first difference column, you calculate second difference. Subtract this from this, put here. Subtract this from this, put here. Subtract this from here, put here. So with the help of 5 points up to 4 difference, you may able to calculate, isn't it? So again, subtract this from here, this value. Subtract this from here, this. Again, this from here, you will get this last difference. This is del y0. This is del square y0. This value. This is del q y0. This is del 4 y0. Okay. So starting, your formula is starting from del y0. It is not starting because derivative formula, original interpolation formula is starting from y0. But derivative formula is starting from first difference value. Okay. So don't confuse about this. Okay. You should not consider the y0 first. In the polynomial, you just consider y0. But here, your first term is del y0. Okay. Now derivative at initial point, first point. What is outside 1 by h? Outside 1 by h. What is h for these data sets? H for these data sets, space length for these data sets. Tell me quickly. What is the space length of x arguments? For this example. अरे स्पेस लेंथ नहीं समझ में नहीं आ रहा वो 1 minus 0 2 minus 1 3 minus 2 4 minus 3 all are same 1, and that is why these data sets is equispace, and that is why we are using the Newton forward interpolation, because asking point or that derivative we are calculating at this point. In this neighborhood, this point is lying. So Newton forward, using Newton forward interpolation, we have derived this formula. We are using this formula now. Okay. So space length is 1 for x arguments. Outside 1 by h. Okay. Okay. Inside del y0 means this value minus alternating series. So del square y0 by 2 means this value by 2 plus this value by 3 minus this value by 4. Okay, you see this formula again. First difference minus second difference by 2 plus third difference by 3 minus fourth difference by 4 plus 5 difference by 5. In that way, plus minus, your series will keep continue. Okay, outside 1 by h. Is it clear?
Yes, sir.
So outside 1 by h means 1 by 1, that is 1. Do the inside calculation with the help of calculator. You just try to calculate. So if you will calculate, this value will be 0.2128. That is the numerical derivative at x equals to 0. This is actually approximate. Better approximate with the help of these techniques. Okay. Now exact value you have got 0.2171. 0.2171 exact. So this is the exact. Exact minus this is the approximate, so approximate. That is the basically error. So whatever this value we will get, that is the error. Okay. The logic is clear.
Yes, sir.
Now tell me, you just see was nicely and try to remember this second derivative at initial point. Second derivative at initial point. Outside 1 by h square, del square y0 starting term is second difference top value. Del square y0 minus del q y0 plus 11 by 12 del 4 y0. Is it okay? Second difference minus third difference plus 11 by 12 fourth difference top value. So if I will ask you calculate d2y by dx2 at first point, d2y by dx2 at first point. So which term I have to consider? My starting term will be second difference, means this is first term minus this is second term plus 11 by 12 this is, isn't it? This is not actually this formula I'm showing you wrong actually. This is at x equals to 1. That is I am telling you little later. So can you able to calculate second derivative at x equals to 0 by watching this structure?
Yes, sir.
Okay. Second derivative at x equals to 0, d2y by dx2 at x equals to 0 will be second difference, del 2 y0 minus del q y0, means this term minus this term plus 11 by 12 this term. And outside 1 by h square. H is 1, so 1 by 1 square. That is the second derivative at x equals to 0. Is it clear?
Yes, sir.
Now I am coming to another logic which is very important to remember. Okay. Now suppose second derivative also you may be able to calculate. Now question is, sometimes it will be asked to you derivative at the second point. Suppose if it is asked to you derivative at the second point, dy by dx at x equals to 1, then what you will do? Okay. So by considering original all data sets, you just construct the difference table. That after constructing that difference table, in the difference table, considering one now first value, which will be the associate upper diagonal elements, that elements you have to pick up. Okay. If derivative at second point, it will be asked to you, considering this one x equals to 1 as the first point, associate elements or upper diagonal difference element you have to pick up. If this is the first point, then associate upper diagonal elements are this. Okay. But if I will consider 1 is the first point now, then what will be the upper diagonal element, associate upper diagonal elements? That is x1, that is corresponding y1, associate upper diagonal will be these values. These three values. Okay. With the help of these three values, you will calculate all the first derivative and second derivative. You can able to calculate all with the help of these 3 points. So what will be dy by dx at x equals to 1? So outside 1 by h and associate to 1, these are the upper diagonal elements. Now this is my first difference value. So this by 1 minus this by 2 plus this by 3 and outside 1 by 1. You got my logic? What I am trying to say here? Whatever the formula we have created, if the second point will be asked to you, then that second point you have to consider looks like first point, and you have to use the same formula which is we have derived. Okay, means that time I have to think that is the first point. Associate to that point which are the upper diagonal, that element we have to pick up and we have to rearrange and find, we have to calculate the derivative, first derivative or second derivative. Is it clear?
Yes, sir.
So if up to this